Means as a constitution. What do I mean by that? What I mean is we need to document entire literature of science similar to a constitution with sections and subsections. Divided the talk into these sections. We'll go by one. So when we look at the structure of the constitution, we have like chapter 1, section 1 and subsection, and then there are the statements of law, act or article, whatever you call it. So those things will be divided under some groups like sections, chapters, sections and subsections. And what happens when you try to add a new statement of law? So legislative body makes amendments to a constitution. Let's suppose under chapter 1 and section 1 and subsection 1, they are going to add a third statement. So they make a decision to add a new law, and then that goes under that particular subsection. So when we refer to that particular statement of law, we say like chapter 1, section 1, subsection 1, and then that is the third statement. That's how we refer to whatever that latest amendment to the constitution. And in short, like we can refer to it as 1.1.1.3. So that's how that particular statement is referenced. So my proposal is the core principles of science should be documented similar to a constitution. Like for example, like you say subject 1 we say physics, and then subject 2 is chemistry. Under subject 1, like we can say branch 1 and then classical physics, and then again there is a section, and then we can call it as force. And under that we have different statements of like whatever that describes the force will be written under that section. So similarly, we have a separate section for gravity, and like that. And then there is a within physics there is another branch called we can name it quantum mechanics, and some other branch like that. So this is how the entire scientific core principles needs to be documented. That's the proposal I am making. And then what happens if we construct a core library kind of thing like that? So that similar to a constitution, this format of scientific publication should also be made available publicly. And gathering the statements, so gather the core statements from openly available content. A lot of articles or books are openly available in so we can collect the statements from them, or gather the statements from abstracts in the articles that are behind a paywall. If some of the articles are behind the paywall, so we can construct the statements from the abstract openly available abstracts. And then if publishers are willing to add a statements from their articles, they could create whatever the summary of those articles, main statements of those articles. They could also add the core points from those their articles into this library, or whatever we call it. So core principles of scientific library. And then so if we add all the core statements in at one place, and where does the actual research, whatever that articles that are being written in journals or everywhere, so these will be the referenced under each point. Whatever the statements we are adding under physics or chemistry, that statement will have all the references that support that statement. Like if there is a new discovery, that discovery made a statement, we add that statement into the core library, and then under that reference was what are the articles that supported this, that discovered this statement, and what are the other articles that are in the future that are going to be using this statement to make another discovery or something. So under the statements we'll have the actual references. Each statement will have the research references which supported that particular statement in a chronological order. So what happens if we have a new discovery? So scientific research results could be published in any of the formats such as a book, an article, a video, or an audio. In any format, so we can publish the scientific research results. And each research publication ultimately establishes a set of statements. So when you write a lengthy article, ultimately you're basically making your case in support of whatever that theory you are trying to propose. So ultimately it's a point, a statement, one line, it could be one line statement, and then the whole article supports that statement. So that particular statement will be part of the library. These new statements should be accommodated into the subject they belong to in the core principles. Just like we make an amendment to the Constitution, new research will add another statement to the core library, or it could replace something, or it could add another one. So whichever the way it may be. So for example, when you look at the physics, and we have two statements, and then third statement somebody discovered about the force, and then we add it at the as a third point in that under the section force. And how do you cite these statements? So when somebody referring to these statements and writing an article, they could cite if they are referring to these statements, so it could be physics, classical physics, force, and then third statement. In short, we could say that 1.1.1.3. So that's how we put the citation for that article. And then example of citation is so when you were writing an article, every action will have an equal and opposite reaction. If whatever that third statement we added is this statement, then we can use that statement in an article and then reference it as 1.1.1.3. So that's how we can cite that particular statement from the core library. If there is no core statement for a discovery that is behind a paywall or within a book, then original reference should be cited in the article. When we started building the library, not all the signs might not be converted into the statements, so some of them still be in articles or books. So in those cases, if you are writing an article, whatever the statements in the core library, refer them as sections and subsections, and then if they are not there, and then you could also refer to the actual source of the research. So this kind of citation is very popular even in the ancient times. So citation referring to sections and subsections is also widespread in ancient texts like Bhagavad Gita and Bible. Even Bible also uses the sections and subsections. So following are two slokas from Bhagavad Gita and their citation. यदा यदा हि धर्मस्य ग्लानिर्भवति भारत अभ्युत्थानमधर्मस्य तदात्मानं सृजाम्यहम् परित्राणाय साधूनां विनाशाय च दुष्कृतां धर्म संस्थापनार्थाय संभवामि युगे युगे. So these are famous, very popular slokas from Bhagavad Gita. So but Bhagavad Gita is not itself is a book, it's part of the Mahabharata, and then it is Mahabharata, and then it's under the Bhishma Parva, that's 11, and then under that it's a chapter 4, and then these slokas are 7 and 8, 7 to 8. So we can in short we can say that Mahabharata and then 11.4.7-8. So that's how we can refer. So that's how we are referring to these slokas from ancient times. So subject gets divided, main summarized into points, and then those points are referred in actually when you're referring to the statements. So this is not a new thing. And the constitution is similar, and then ancient Bhagavad Gita or Mahabharata or take Ramayana, all are slokas, and then you can just point to which sloka you're referring to, which chapter and which sloka you're referring to. So for them, if anybody interested in the meaning, so this is the meaning I copied from Paramahamsa Yogananda commentary on Bhagavad Gita. So that commentary is like O Bharata, so that is Arjuna, whenever virtue declines and vice predominates, I incarnate as an avatar. In visible form, I appear from age to age to protect the virtuous and to destroy evil doing in order to re-establish righteousness. So that is the meaning of the slokas. So when you look at why we need to build the science in similar to the constitution, because there are so many obstacles to the progress of science, as I elaborated them in my previous talk number 8. I mentioned that peer review is one of the main obstacle for the progress of science. You cannot publish anything that easily, and each one had different kind of format of citations, and absence of theoretical journals. Most of the journals needs experimental data, so it's very difficult to publish a theoretical theory based article. Journals are expensive. You can't afford to read all the articles in the journals and then cite them. If you want to use them, you don't know what those articles are referring to. So that's why we need to have a common library. So citation issues, people, so it says like you need to use only the journal references, but science is everywhere. But like some people use their own books, but they won't refer experts written in written books from outside the academia. So those citation issues, selective citation, basically what I am saying is selective citation issues will go away. So wherever you publish, if it is a science, when you establish a point, that points need to be added into the core library, and then that point in the library will be cited in any of the article that has been written. Plagiarism check, so that also will go away. So if somebody made a point, and then later somebody else stated that point, most of the like if that second guy is from academia, he get more popularity. So but the first one gets forgotten. But if we build a core library, if we make it that point, even though the second one gets a popularity in the beginning, but later if we find out the first one is the one who actually proposed that point, then we put his research as the first and then the second as the whatever that is second research paper, and that's how we will have exact true plagiarism check if we build with this kind of structure. So selective publication in popular media. So popular media picks up only famous scientists articles and then popularize them. But if we have core library, you know the worth of each statement, and then automatically that get its value gets known automatically. So how to overcome these obstacles, how the new structure of science overcomes the obstacles to the progress of science. So peer review, how we can get over the peer review? So we publish first and then review later. So that lot of review could happen later as well. So publish anywhere and then let that make whatever the point it makes, add that to the library, let others disprove it. That's how it has to happen. And the theft of research gets eliminated. See, you make a huge discovery and then you try to publish, you never get published because you're going around journals and journals, and then 10 years down the time somebody else picks up the article from somewhere, and then he gets the popularity. So that kind of theft in the research gets eliminated if it is with this kind of format. So absence of theoretical journals. So because we are publishing anywhere, like it could be YouTube video, or it could be a newspaper article, it could be an audio file somewhere, and it could be a research article in a preprint server. So anywhere you publish and then take that point and put it in the library. So that way, lack of theoretical journals, that issue will get resolved. Expensive journals, and then because the main core points of science is in open, so you don't need to worry about that expensive journals. So plagiarism check, even after an original research comes to light, after a statement has been established by some other research, the original research will have chronological precedence to that statement. So that citation issues, citation to the statement, not to the research. Uniform citation format makes it easy to document the research. Selective publication in popular media. So open statement in core principles established by a new research will be visible to everyone. Appreciation of your discovery is instantaneous. So that's how we will benefit from that building the core library of science. So what I say is, there is no stagnation in fundamental research. Present theories are not providing satisfactory explanation to many observations in the nature. There are plenty of alternative theories in books, articles, and videos outside the popular media. These theories are not being looked into. They should be made part of the academic curriculum. So what needs to be done to make these alternative theories to be part of the science? So that's the question I posed in my last talk. So the answer is, document the science similar to a constitution with the core points from the research. So in summary, thousands of books and articles exist today, including the ones from ancient times. All have a lot of scientific valuable information. Moreover, new research is published in many different forms, including articles, books, and content in the form of audio and video. It is not possible for any single individual to grasp the content of these publications to gain an holistic understanding of science. So that is immense. Like, there are a number of articles, and then the content, the books are so many, you cannot read them and then understand science as a whole. AI, people say now the talk of AI is so much more, and then people say AI could do it, but that's not a solution. AI could summarize it, but it cannot enable extending the science, writing an article. So you cannot reference to those points. So summarization doesn't help. We need entire library with a points. So the solution is to document the core principles of science into sections and subsections similar to the format of a constitution. Education and research should be concentrated on reading and referring to these core principles. This is the only way for this stagnated science to advance into the future. That's the idea I'm proposing. So this talk is as part of the series I started early in 2024. So these are the talks I gave earlier. So basically, the series I named is "What is holding the science from making a big leap forward?" Um, and then this is the ninth talk in the series. So what I included in the series is I gave an introduction in the beginning, and then few of my discoveries in details, and then drawbacks in publishing the research results, and then ideal environment to publish the research papers. So ideal environment I was referring to in all these talks, and then emphasized in the previous talk is this: build the science as a constitution with sections and subsections and chapters, sections and subsections, like that.